Fascinating opportunities exist for scientists and engineers in the field of alternative energy technology. Scientists and engineers working in alternative energy do all sorts of interesting things which have a positive impact on our future. We hope to inspire you to think about becoming involved in this field. You may someday come up with the next big innovative idea. With growing worldwide energy needs, there are many societal benefits to deriving energy from sources other than fossil fuels. Since alternative energy comes from renewable sources, it offers the potential to meet our energy needs on a sustained basis. Alternative energy also offers the potential to improve the quality of life of people all over the world. Alternative energy sources include solar, bioenergy, hydropower, ocean energy, geothermal, wind, and fusion. Aspects of solar energy include photovoltaics, solar heating, and solar fuel production. Photovoltaics is the science of generating electricity using sunlight. A photovoltaic cell, also known as a solar cell, absorbs sunlight, causing valence electrons to travel through it in a controlled manner to produce useful electrical current. Valence electrons are the outermost electrons of an atom and participate in being shared with neighboring atoms or in being transferred to other atoms. A conventional solar cell consists of layers of specially treated silicon-containing material. A layer with added atoms having one more valence electron than silicon is known as an N-type semiconductor. The N is for negative. A layer with added atoms having one less valence electron than silicon is known as a P-type semiconductor. The P is for positive. Solar cells absorb sunlight and then transfer the absorbed energy to valence electrons. Energized excess valence electrons from negative layers then travel to electron-deficient positive layers, thereby producing electricity. Solar heat can be utilized to produce electricity in a practice known as concentrated solar power. Concentrated solar power systems have specially designed mirrors which focus the sun rays to generate intense heat. Heat-storing fluids transfer the heat to either a steam turbine or mechanical device that drives an electric generator to produce electricity. Thermal storage systems store the heat generated when the sun is shining, allowing it to be used when the sun has set or is blocked by clouds. A variety of research on solar energy is being done. For example, nanotechnology is being applied in investigations of different types of solar cells. Nanotechnology is a relatively new discipline involving the study of molecular structures on the order of nanometers in size. A nanometer is a unit of length equal to 1/1,000,000th of a meter. Due to their size and shape, such structures can possess unique properties. For example, nanometer-scaled molecular structures comprising solar cells can potentially absorb a greater amount of light across a wider wavelength and more efficiently convert it into electricity than can conventional solar cells. A novel area of research involves using solar energy to recycle carbon dioxide by converting it into fuels. Photocatalysts are being investigated for this purpose. Catalysts are substances which speed up the rate of a chemical reaction without being consumed in that reaction. Research is being done to develop photocatalysts which facilitate conversion of carbon dioxide to various low molecular weight hydrocarbons, with sun energy driving the reaction. Additionally, concentrated solar power technology is being developed to convert carbon dioxide to carbon monoxide and break down water to produce hydrogen. These reaction products can serve as starting materials for producing various fuels. Some of them, such as low molecular weight hydrocarbons and hydrogen, can be used directly as fuel. Bioenergy is energy derived from organic material obtained from renewable natural sources known as biomass. Biomass includes agricultural and forestry residues, municipal solid waste, industrial waste, animal waste, and crops grown specifically for energy conversion. Biomass can be used as feedstock in producing a range of fuels known as biofuels. Various chemical and biochemical processes convert biomass to biofuels. For example, a series of catalyzed chemical reactions are used to deoxygenate, break down, rearrange, and isomerize lipids from algae to produce a complex mixture of branched and cyclic alkanes and aromatic hydrocarbons, which comprise jet fuel. Lipids are a class of water-insoluble natural compounds which serve various purposes in organisms, such as energy storage and as a component of cell membranes. Algae are particularly well suited as a lipid source due to their high lipid content and high growth rates. Much progress has been made in developing biofuels. In the case of biomass-derived jet fuel, performance characteristics superior or equal to that of conventional jet fuel have been achieved. In the United States and other countries, several successful test flights of commercial and military aircraft powered by biomass-derived jet fuel have been completed. Bioenergy research and development efforts are aimed at investigating new and further developing existing bioenergy technologies, reducing their cost and putting them into practice. A tremendous amount of renewable energy is present in the oceans. Types of ocean energy include wave energy, tidal energy, ocean current energy, ocean thermal energy conversion, and salinity gradient energy. Waves are produced mainly by the action of wind. Areas of the world particularly rich in wave energy include the western coast of Scotland, northern Canada, southern Africa, Australia, Hawaii, and the northeastern and northwestern coasts of the United States. Tides are produced mainly by the gravitational pull of the moon and sun. Rising and falling tides produce tidal currents which are bidirectional and reverse direction 4 times daily. Tides sufficiently strong for energy production occur in many places all over the world, with the highest tides in the world occurring between Nova Scotia and the state of Maine and near Alaska. When ocean water freezes in polar regions, salt is left behind in the surrounding water, causing it to become more dense and therefore to sink. Surrounding surface water then comes in to replace it, and the cycle continues. This process, as well as the action of wind, form the basis of ocean currents. Ocean currents move continuously in one direction and at a relatively constant rate in fixed paths, traversing oceans all over the globe. In the area of the United States, the Gulf Stream is an ocean current and travels through the Gulf of Mexico, around the tip of Florida, and up the East Coast. Many different types of wave and tidal energy devices are in use or being developed. Some are used underwater, some at the water surface. These devices employ various different techniques to harness the kinetic and potential energy inherent in the water. Places where this type of work is being done include Nova Scotia, France, Scotland, England, China, South Korea, Portugal, Australia, Russia, and the United States. At present, there are no commercial ocean current energy facilities in operation. However, various techniques to harness ocean current energy are being investigated. Ocean thermal energy conversion, also known as OTEC, takes advantage of the temperature difference between colder, deep ocean water and warmer surface water in tropical coastal regions. One type of OTEC system employs a process whereby warm surface water subjected to a low-pressure environment is converted to steam. The steam drives a turbine connected to an electrical generator to produce electricity, and cold water pumped from the deep condenses the steam. Current research on OTEC is aimed at improving the technology and reducing cost. OTEC offers interesting side benefits. Cold water from OTEC operations can be used for refrigeration or for air conditioning in buildings. It can also be used to chill soil, allowing temperate climate plants to grow in warmer climates. It can also allow farm production of aquatic species not otherwise amenable to growing in warm climates, including salmon, trout, lobster, clams, oysters, and commercially valuable algae. Some OTEC systems produced desalinated water from the condensed steam. Places in the world with existing or planned OTEC research facilities include Hawaii, Florida, the Republic of the Marshall Islands, and the Republic of Nauru. Salinity-graded energy is possible when fresh water joins salt water, as in the case in places where a river flows out into the sea. Due to their differing solute concentrations, salt water and fresh water differ in water pressure. When such solutions are placed on either side of a membrane permeable to water, but not to ions, water will pass through to the higher solute side to equalize the pressure. This is known as osmosis. A facility in Norway derives energy from the increased water elevation on the saltwater side of such a system. The water is released and used to turn a turbine. Energy can also be derived from ion concentration differences between salt water and fresh water in a process known as reverse electrodialysis. This process employs membranes selectively permeable only to anions or cations. Salt water in a container is separated from fresh water by a cation permeable membrane on one side and an anion permeable membrane on the other. When salt water moves through the container, sodium ions pass through the cation permeable membrane, and chloride ions pass through the anion permeable membrane. The resulting charge separation produces a voltage, which can be converted to electrical current. A facility in the Netherlands produces electricity using this process. Geothermal energy is the heat present in the Earth's crust produced from radioactive decay of materials in the Earth's core. This heat is stored in underground reservoirs of steam, hot water, hot dry rock, and magma. Magma is partially or completely molten rock. Geothermal energy can be used in different ways depending on the temperature of the geothermal resource. Heat from hot water can be used for such things as heating homes and buildings, commercial greenhouse operations, commercial laundry operations, fish farming, dehydration and food processing, milk pasteurizing, and heating swimming pools and spas in resorts. Some localities have placed hot water pipes under roads and sidewalks to melt snow. Hot water or steam from higher temperature sources is used for generating electricity via steam turbines. Cold water can be pumped into hot, dry rock via a well to generate hot water or steam. Work is being done to access heat from magma as a geothermal source. Because of its close proximity to intense volcanic activity, Iceland is able to generate a significant amount of its electricity from geothermal sources. Fusion can potentially produce tremendous amounts of energy, but has not yet been successfully put into practice. Fusion is a chemical reaction which releases energy from nuclei of low atomic weight elements combined. Under the right set of conditions, collisions of atomic nuclei are sufficiently energetic to overcome their electrostatic repulsion, allowing them to fuse with one another. The amount of energy released is determined from Einstein's equation E equals mc squared, where m is the decrease in mass between product and reactant nuclei, and c is the speed of light. Many different fusion reactions are possible. The heat and light from the sun is produced from fusion of hydrogen nuclei in the core of the sun. Fusion of deuterium and tritium is being investigated as a potential renewable energy source. Deuterium and tritium are isotopes of hydrogen. When deuterium and tritium nuclei fuse, energy is imparted to a released neutron, causing it to travel at high speed. Fusion of deuterium and helium-3, which releases high-energy protons, is also being investigated for this purpose. Helium-3 is an isotope of helium. Useful energy is expected to be obtained from released neutrons when the neutrons strike a surface, thus producing heat. The heat can be used to produce steam, which in turn can drive a turbine connected to an electric generator, thereby producing electricity. Energy from released protons can be captured using electric or magnetic fields or solid-state electronic devices and then directly converted to electricity. Fusion research is being conducted in places all over the world. An international research facility is being built in France. Research at this facility will be done in collaboration between the United States, Russia, the European Union, China, India, Japan, and South Korea. Research at this facility is expected to begin in year 2018. As we have seen, much interesting work is being done on alternative energy. With a little imagination, all sorts of creative ideas can be thought of for improving ways to use alternative energy or for finding new sources of it. Who knows? Yours may be the next big idea. Ensuring good quality, sustainable living conditions for future generations presents many challenges and will require our continued efforts. Alternative energy offers great potential for achieving this goal. There are many opportunities for research, development, and implementation of alternative energy technologies. Maybe you will consider a career as a scientist or engineer and help to achieve our common goal of harnessing the power of renewable energy sources. This concludes our look at alternative energy. We hope you have enjoyed this film and that you might feel inspired to become more involved in advancing the use of alternative energy. Log on to acs.org for more information about these exciting careers, and check out earthday.org to see how you can get involved right away.